port will also have a light. So it is associated with all these ones, stat, duplex, speed, they are associated with the different ports. Oops. Then the port duplex light it indicates, if it is green, that the port is in duplex mode. You have read about the duplex as well as the half duplex mode in 155. So when it is green, it indicates that port duplex mode is selected, and then the port speed indicates that speed mode is selected. So you can select whether you want to transmit the data at 10 Mbps, 100 Mbps, or 1000 Mbps. The last one is the power over Ethernet LED. It's present if the switch supports the power over Internet, and the green button indicates that it has this power of Ethernet enabled. Then the last one is the mode. It's a sort of physical button that you could press to switch between different modes like stat, duplex, speed, and then you can switch between these by pressing this physical button mode on the switch. If you have seen the switch, it would be very easy to understand this. If you have not seen the switches, you might want to Google the image of the switch and you will know it better what we are talking about. Let's see what these indicators and what the associated colors mean. So the LED would be in one of the five colors, and or in off state. So essentially it is off or on. When it's off, there will be no color. If it is on, there will be 5 color options. So one's green, one would be blinking green, the third would be amber, fourth would be blinking amber, and then the final one would be alternating between green and amber, which mostly portrays a fault. So for example, if a RPS is off, or there's no RPS button, it means that there's no redundant power supply. If it is blinking green, it means that it is up, but it's not available. Similarly, once you select mode, so for example, if we check stat, stat is the spanning tree protocol. It's associated with spanning tree protocol, which helps prevent the flooding in the network. For example, if you have a loop, we'll know or discuss more about loops in detail in further lectures to come. But if your network is in loop and sending data in loop, it will flood the network. So then you use the spanning tree protocol to block some of the ports in the network. So this light associates for that. So if it is off, it means that there's no link or it is in shutdown. If it is, say, blinking green, it means that there is activity happening on that particular port. If it is in amber mode for some port, then it means that that port is blocked for preventing the loop. Again, if it is blinking amber, it means that the port is blocked for preventing the loops. For duplex, if it is off, if there's no indicator, it means that the configuration mode or that port is in half duplex mode. If it is green, it will be in full duplex. There's no blinking amber or blinking amber or blinking green. Then again, if this speed LED is off, it means that the speed of the port is 10 Mbps. If it is green, it means that the speed is 100 Mbps. And if it is blinking green, that means that the speed of that port is 1000 Mbps. So these two work in, say, half duplex mode, and then the 100 Mbps one works in the full duplex mode. Okay, so what happens if a switch crashes? Like if you're working on a switch and it immediately crashes, or after you're working on a switch, like after some time it crashes. So what happens if we were in a physical location? We know that if we had a switch with us, I could show you how it would happen using the terminal emulator software, such as the TerraTerm or the HyperTerminal. But now we do not have that anymore. So you'll just have to use your imagination to understand this. So the bootloader provides access into the switch operating system. And if it has damaged file, or if it is not available, then you'll not be able to say converge to that switch, or you'll not be able to load that switch. Otherwise, what happens is that you power on, you have a switch, right? Imagine that you have a switch, you have RJ45 cable or a console cable. You put one of the end in the switch and the other end in your PC, maybe an RJ45, or maybe you have a converter from RJ45 to USB. And then you use the terminal emulator software to access the switch. You'll be able to do that. We'll be simulating that in Packet Tracer. So you use that terminal emulation software to connect to a switch from a console cable, right? But what happens if it crashes? So what happens if it crashes is that you already have that connection of the PC by console cable to the switch port, right? And you have configured the terminal emulation software in your PC to connect to the switch. The second step you would do is you would unplug the switch power cord, or say you would turn off the switch. The third step is that you reconnect the power cord of the switch, or you turn on the switch, and within the very first 15 seconds, you press and hold the mode button that we have seen in here. So you press this button in the first 15 seconds. Uh, and the system LED will, and while you are pressing that, the system LED would be flashing green. Then the fourth step is that while you're continuing to press this mode button, the system would turn briefly amber and then to the solid green. And when it turns to the solid green, you release the mode button. And in your terminal emulation software, such as TerraTerm, you'd see the switch loader window prompts with this one, switch and colon. Otherwise, it would be switch and a greater than sign. But now once you do all these 4 steps, it will be switch and this button. But one question is that why do we need to do that? You know, sometimes you forgot the password, or you need to reinstall the operating system, or you want to format the flash drive. So then all these things can also come in handy, just not the crash, but if you want to say forgot the password of the switch, then you might also want to repeat these steps in order to reconfigure the switch. And then the bootloader commands and then some other commands help you reinstall the operating system software, such as we saw the boot command that gave the directory link, that gave the link of the address of the iOS image file to the loader from where you need to load the command from. So you can use all these similar commands to again reinstall your switch so that it works fine after a crash. Then the second important thing to understand is the switch management access. So most of the time the switch is not available to us physically, right? So we just need to connect the switch from a remote network, like in this setting. Once we are, if we have the access to University of Essex laboratory, we could have remote access, right? We are not physically going there. So for that, we need to have management interfaces. And then there's important term known as switch virtual interface. So to access a switch virtually, you need to have the IP address assigned to this switch virtual interface. Uh, and again, to manage the network remotely, the switch must be configured with the default gateway. So this is the similar concepts that you have learned in CE 155. You know how to assign IP addresses to the switches as well as to the PCs. The similar IP address you would assign to SVIs, so the virtual interface. And then like nowadays you have the IP CCTVs, the IPTVs. So you just need to enter the IP address and then you connect. It would not be a physical port, but it would be a virtual interface, and then you could have sort of a virtual console cable to connect to that port. Let's read over what is written. So to manage the switch from a remote network, switch must be configured with default gateway. Yes, we need to configure the default gateway. We need to provide IP address as well as a subnet mask. This we have written. So it's not a virtual interface, sorry, it is a virtual interface. It's not a physical interface. It's not a physical port on a switch. It could be accessed using the PC console cable to do the initial configuration, or if you want to manage or configure the network remotely, you need to have this IP address, subnet mark, and default gateway assigned to this virtual interface so that you can access it remotely. Let's try to see that. Let me open Packet Tracer and see what I'm talking about. Are you able to see my Packet Tracer? I believe no. I again need to stop share. No, it's stop video. Share Packet Tracer. Okay, I suppose now you're able to see my Packet Tracer, right? Now if I switch to presentation, you will not be able to see presentation. Okay, I'll have to stop share again then. But again, what I was talking about is that let's have So in this packet tracer, you'll download the packet tracer from the either Moodle or the Netcad website. So we have network devices. These are all the routers that are there. So we were just focused on switches now. So this is the switch tab. Let's have a 2960 switch. From the end devices, we have a PC. For now, these should be okay. From the cables, you have a straight through cable to connect. Say fast Ethernet 1 to fast Ethernet 0. Let's give a bit of time to load the switch. Okay, so it has started. You know the command to go into the initial configuration. It's enable. Let's do it from the console cable as we've seen in the slide. So we'll have a console cable 232 and we have a console. So with this console cable, you'll be able to access this switch remotely. So rather than going into the configuration setting of the switch, we can go into PC, desktop, terminal. Okay. And now you can see the command that I issued on the switch. You can see the same on the console cable, right? So this is sort of the physical connection. If you want to have the remote connection, you need to have the virtual interface, SVI, switch virtual interface written on it. Let's see the initial settings. So for that, you need to run the command show running configuration or show running config. If you press enter, then you could see like the current configuration. It's very basic. So you have no service timestamp, no service password encryption. The host name is default switch. There's no interface that we have set up, and no virtual interface that we have set up. So this VLAN 1 is the management interface that's there by default. And we have not done any of the settings in it. Let me again share my screen with the PowerPoint. Oh, you mentioned that did you not see the pop-up? Let me go over again and then check out what was the problem. So this one, I suppose you are able to see now. So by default, we have seen that the management interface is VLAN 1 by default. It's the management interface that is already there on the switch. But for security purposes, it's considered best practice not to use that VLAN 1, but to use the other management or to create the another management VLAN. Right? I'll just show you in a minute how to create a new VLAN. But to configure the switch SVI, the very first step is configuring the management interface. So from the VLAN interface configuration mode, we'll assign an IP address as well as subnet mask to the SVI switch. And then we will note that the switch would not appear as up until it is created, and then it will be up only when a device is connected on that VLAN port. Also to note that switch may need to be configured with IPv6. For nowadays, we always support both IPv4 as well as IPv6 settings. So you need to configure the IPv6. For the IPv Cisco 2960 to run an IPv6, it needs to run on the iOS version 15, which is not there on the packet tracer yet. Funnily enough, Cisco should have updated that, but by default, the iOS version in the packet tracer is version 12, which does not support IPv6. So it would not support the SDM pref or dual IPv6 command. But if it supports, you need to issue an SDM pref for this is switch database management. So the dual IPv4, IPv6. And if you do issue this command and then reload the switch would be able to handle both IPv4 and IPv6 packets. Let's try to see if you can maybe take a screenshot for this. So I can try to show you in the packet tracer, and you can refer to this on your like mobile phones, or if you take an image, then you know better what I'm talking about. Let me stop share and share the packet tracer. So, okay, I see what you mentioned. You're not able to see my this pop-up. Screen option and sorry, what do I need to do? Let me just see what you mentioned. Can you share screen rather than windows? Oh, I am sharing screen, I suppose. Okay, I'll do that. Yeah, screen share and then sharing the screen. How do I do that? It doesn't have that option. Files basic. Let me try to see if it works. Are you able to see the settings now? Yeah, I suppose it does the. Yeah, okay. Thank you. Thank you for suggesting this. Every day is a new day to learn something new, right? So where was I? Let me see if now PowerPoint works. Yeah. So we were to configure SVI, right? So sorry, so let me just repeat what I did initially if you guys have not seen that. So from the console cable, I put on the console cable to go to the this switch setting rather than going from the command line interface from the switch. We could use this console cable and go to the same switch setting from the terminal in the PC. And then I was just saying that I issued a show running configuration command. You could see that there's nothing specified in any interface. Everything is empty. It's the initial setting. There was in interface VLAN 1, which we mentioned was the default VLAN, default management interface, but it did not have any IP. It was shut down. There's no line console, no virtual terminal line selected. Now let's try to create a new VLAN. So we are already in the enable mode. So let's do configure terminal. So we are in the configure terminal mode now. If you have rusty concepts, you'd know that this configure shows that you are in the privilege access mode. So you can now do all the manipulation of the configuration files that you want. So as we just seen that it has a management interface VLAN 1, but for in order for us to create a new VLAN, we issue a new command called interface VLANs. We could put in any name. Let's suppose VLAN interface VLAN 99. Now if